This presentation goes through the CRISP-DM framework. CRISP-DM stands for Cross-Industry Standard Process for Data Mining. It was initially built for data mining projects, but it's a framework that's very useful in industry for analytics projects, as well as for all types of problem-solving projects. This presentation is going to go through the 6 steps within this framework. Before we get started, we've all heard how data is the new gold rush for business. However, what really matters is how you go about converting that data into value. There's no magic in how you're going to do that and how you turn your data into gold. The process of how you go about doing that is really one of the most critical things to do. And so a standardized process for an analytics project is extremely important to create a standardized way about doing a project so that it can enable us to learn from our mistakes as well as optimize our different steps along the way. It makes it so that it drives good habits and practices for us so we can continue to learn and optimize our approach. It also makes the process more reliable and repeatable so that others can follow the steps that you have done and allow for us to learn from that. So the CRISP-DM framework breaks down the analytics project's lifecycle into 6 phases. The visual representation here shows the 6 different phases. As you can see, some of the arrows go back and forth because this is an iterative process. It all starts with a business understanding, which is followed by your data understanding. So you need to work with the understanding of the data so that you have some kind of understanding of it and able to see the different elements of the data and how it's going to be used for different parts of modeling and how you can use it to solve a problem. We have a data preparation element, a modeling phase, evaluation of the model, and then finally deployment of that model. As I mentioned earlier, this is an iterative process, so that means that it's not a linear approach. As you go through it, you may need to go 1 or 2 steps back so that you can continue to refine your approach and execute your project. Here we have a table that shows a high-level view of the elements in each of the different phases and tasks within our framework. The first phase of CRISP-DM framework, which is the most important phase of this framework, is going to be that business understanding. What are your business objectives that you're trying to solve? What's the overall data mining objective that you're also trying to solve? How are you going to measure success for this project and the criteria that you're going to use to measure success? So creativity is going to be an important part of this phase in being able to use your business knowledge and understanding as well as working with others to effectively delineate the business problem that you're trying to solve and how you are going to convert that to a specific analytics project or data mining objective. Again, the focus here is going to be on understanding the project objectives and the requirements from that business perspective, and then converting this knowledge into an analytics problem definition. And then you're going to have a preliminary plan designed to achieve these objectives. So we want to begin with that end in mind, and how are we going to achieve this business objective using our analytical approach. So of course the first phase is determining the business objective. You really need to understand from a business perspective what your client is wanting to accomplish and uncover important factors at the beginning that can influence the outcome of your project. If you neglect this step, you're going to spend a lot of effort producing the right answer for the wrong question. You can spend a lot of time and effort on your project, and it can be completely off base from what your client has asked for you to do. I cannot tell you enough how important it is to make sure that you're working on the right problem up front from a business perspective, as well as from an analytical perspective. You'll want to assess your situation with more detailed fact-finding about the resources, constraints, assumptions, and other factors that you need to be considering as part of the overall project that you're working on. You really want to get all of this information up front so you don't have to go back and redo your work at the back end. You'll also want to flesh out the details to make sure that you have all of the important elements for the project that you're working on. So, for example, you might want to know information such as limitations from the data that might be pertinent to the analysis of your project. So let's continue here with the business understanding. You want to determine the goals of the analytics project. So the business goal states the objectives using business terminology. Your data mining goal is going to state the objectives for the project in technical terms. So for example, your business goal may be to increase insurance sales to existing customers. That might be the goal that your client wants you to achieve. But then your data mining goal would be to predict what insurance products a customer will buy given their purchases over the past 3 years, their demographic information like age, salary, city, and the price of insurance coverage that they are being offered. So you see that the business goal is stated on a more macro level, and you see that the data mining goal is a little bit more specific and actionable. And with the data mining goal, you're looking at a specific parameter to try and predict something. You want to come up with a project plan that describes the intended plan for achieving the data mining goals as well as your business goals. So again, part of this is important to have that clarity up front as you're going to go about doing things that align with the overall objectives of your project. Your plan should specify your anticipated steps that you're going to perform throughout the rest of your project. So that's going to include an initial selection of your tools and techniques. So again, you want to begin with the end in mind and start drafting what that plan would look like so that you can start optimizing the best practices as you go through and you start being much more efficient with your project. The next phase is exploring your data. So data understanding includes exploring your data, verifying the quality of your data, and looking at the outliers. And you also need to know the limitations of your data. What's actually going to be good quality in the data that you have. There may be some data that's just not usable, so you want to factor that in as well, and you'll be using that in the overall assessment of your project. You want to be very familiar with your data first, so that should be the first thing that you do before you do any kind of modeling. You need to get an understanding of the structure of the data, limitations of the data, and some of the underlying characteristics, but by looking at the descriptive statistics of your data. You will want to identify the quality problems that you have and maybe discover some insights into your data first. So, what variables are correlated to other variables could be some interesting information. You might want to look for interesting subsets and relationships that may help you form hypotheses from hidden information as we start looking at the data. And so those are all some interesting things that you could look at. And that's also why it's important for you to report on your fundamental exploratory data analysis in your study as well. Give the person who's reading your report a good foundation, a good background of what data you had to work with before you go into talking about what you did, to how you use that data to model your scenario. So you want to collect your initial data set and acquire within the project the data that's listed in your project resources. So what are the critical data elements that you'll need to solve the problem? Include data loading if it's necessary to understand your data. So what this means is that there may be data that sits in different systems, and you may need to collect, extract, and load them all together so that you can start understanding the data. As well as some of the data preparation steps that might be needed to get the data into the right format so that you can use the data. You might want to be able to describe the data, examine the properties of the data, and then report on the exploratory data analysis results. So those are all going to be important steps to make sure that you understand the data that you have. Continuing with exploring the data, this tackles the data mining questions, which can be addressed using querying, visualization, and reporting. This could include distribution of key attributes, some of the simple aggregations. So what are the means of certain variables? What are the relationships between pairs or small numbers of attributes? What are the properties of significant subpopulations? Simple statistical analyses. It may address the data mining goals directly. And what we mean by this is you may do a project that is just as simple as telling me about the correlation between X and Y. You know, how is the propensity of a customer to buy a product related to the age, as it could be an example. That may be all that your client is looking for, is if there are age groups of customers who have a higher propensity to purchase an insurance policy. So once again, that may be all that the customer is looking for. So sometimes something simple as what's being addressed in your data, in your exploratory data analysis, could be the data mining goal for your project. It may also feed into transformation or other data collection that might be needed. So going back to the age example, you may need what's interesting to your client. So, you know, for example, age. You have age as a continuous variable, but it might be more valuable for them to look at it in terms of buckets. So 18 to 32, 33 to 57, and so on, as opposed to looking at that continuous variable as it currently exists in your data set. So as you go through your data, you may find that grouping things might be better than keeping them as continuous variables. And that will sometimes become apparent as you go through the exercise of going through your data in your exploratory data analysis. You want to verify and examine the quality of your data by addressing questions like, is my data set complete? Or are there missing values in my data? You're trying to see if you need to impute some of those missing values, and if you need to, how do you plan to do that? What are you going to do with your missing values? So make sure you have a plan that's documented for what you're going to do with your missing data as well. The third phase is data preparation. This is really where you spend 60 to 80% of your time. And so it involves the collection of your data, the assessment of your data, consolidation and cleaning of data selection and transformations. There are whole books on this topic alone. So it's one of the most tedious processes that you'll go through in your overall project. And so that's why it's going to take 60 to 80% of your time. It's going to cover all of the activities to construct the final data set from the initial raw data or sets, and it's likely to be an iterative process for most of your projects. So there'll be multiple times in which you'll have to go back and forth from an earlier phase to try and go through preparing your data for analysis. You may find things in your data preparation phase that result in you needing to adjust your data mining objectives and how you're going to go about solving your overall problem. So going more detail about data preparation, first thing you're going to do is select your data. You're going to decide that on the data that's going to be used for analysis, and this may be based on the quality of data and how it relates to your objective as far as how useful it is in solving your data mining objective. Criteria can include the relevance of your data mining goals, the quality, is it good quality or not, technical constraints such as the limits of the data volume or data types. Sometimes there are legal elements to it as well, so sometimes we're bounded by what we can use from a legal perspective. So for example, oftentimes we're going to be barred from using race as one of our variables. We may have access to that data and you might find something interesting from it, but you're not allowed to use it. So you'll have to go through that assessment phase of determining what you can and cannot use based on the criteria that are mentioned. It covers the selection of attributes as well as selection of records that are going to be used. And then you'll also have to clean your data. This again is one of the more tedious parts of a project. If there are quality issues with your data, you may need to go through and actually address them. It may involve the selection of clean subsets of data and the insertion of suitable defaults or more ambitious techniques, such as estimation of missing data by modeling. So when there is some missing data, you can assign their values by using some kind of algorithm or model that you come up with. Then you're going to construct your data. This involves data preparation operations such as the production of derived attributes. You create entire new records or transform values from existing attributes. So for example, if you were transforming age into buckets, you would need to go through that phase of constructing a new variable using the existing variable of age. Then you'll be integrating the data, and that's when you combine information from your multiple tables. So if you're pulling information from different sources, you need to put it together into one table using a unique identifier and create a new table and a new record from the subset tables. That's also part of your project. Sometimes you'll need to reformat your data and transform some of the formats of what you have in your data set, especially if your model requires a specific type of data. For example, it might be looking at a classification problem where the client wants to know if the sales are going to be high or low, with the definition of high being over $1 million. So you would go back through your sales values and reclassify that variable from a quantitative continuous variable to a categorical value, also known as an ordinal nominal variable, where 1 would represent values over $1 million and 0 would represent values less than $1 million. And then at that point it becomes a factor. So it's no longer going to be a continuous variable. It's now going to be a 0-1 binary factor variable. So even though it's going to look like a numerical value, it's not going to be a continuous variable anymore. That coding is numeric just because we're using that type of symbol within our statistical software. So depending on the software that you're using, you may need to go in and make sure that the software knows to treat your variable as a nominal or factor variable as opposed to a continuous variable and use the appropriate levels. The next phase will oftentimes be the most fun. This is our modeling phase. It is the part where people tend to think you spend most of your time, but actually it's not. It is really one of the areas that you don't spend much time in at all. So you've got to select your modeling technique based on your data mining objective. You will build your model and set your parameters, and then you will assess your models and rank the models that you have developed, and then assess the models to select the best model. So once you select the best model, then you may need to calibrate that model to obtain optimal results. So going into selecting a modeling technique a little bit more, you can choose from a variety of modeling techniques, including regression, decision trees, neural networks, SEM. There are several types of techniques out there. It is really going to be based on what data you have access to, what you're trying to do with that data, how the data is formatted, and so forth. Sometimes you will need to utilize multiple methods, and so when you do that, you're going to do each of the methods separately, and then you're going to generate a test design. What this means is that before actually building the model, you'll generate a procedure or mechanism to test the model's quality and validity. So, for example, in a classification model, you might use error rates as the quality measure. So for you to do this, you will typically separate your data into a training data set and a testing data set. You will build the model on the training data set and evaluate the model for accuracy and quality on the test data set. When you evaluate the model, you need to test it on data that it has not seen before so that you can see how well it works with the new data, and that it gives me a good feel for what the new data will be. So this is going to be similar to why professors will word things differently on exams from how they word it in class. So they're evaluating if you know what you're talking about, or if you're just repeating back to what you said to them or they said to you. And then you build your model, And you assess the model, as we said earlier. So you assess it if it is aligned with your objectives, meaning that you need to reduce your error rate on some problem that you have. That is going to be my analytics objective. But perhaps it is not related to your business objective. Here is where you assess the model performance based on your overall objectives. This is also involves some level of business understanding. So in potentially working with another business analyst to discuss whether or not the results that you have are adequate for your overall business project that you're trying to solve with your analytics project. Moving into evaluation and validation phase. In evaluation, you're looking at how well your model performed on test data. The method and the criteria for evaluating your model is going to depend on the type of model that you're using. So for example, a regression model that has different criteria for evaluation than a logistic regression model or a decision tree. Interpretation of this model is the important part of the process. So some models are going to be easier to interpret than others. But so for example, you could have a model using regression, but you had to transform your variables to make the model work. So in this case, the interpretation of the model might not be as clear as it might have been if you do not need to utilize a data transformation. You want to thoroughly evaluate the model and review the steps executed to construct a model so that you can be certain that it properly achieves the business objective that you have from the beginning. So when you evaluate your results, you're going to assess the degree to which the model meets the business objectives. Again, at the beginning of the project, you set up what the success criteria are going to be and what it would look like. And so now we're evaluating the model performance and validating the results based on those criteria that we set up earlier at the beginning. Then we are going to see if there's a business reason why the model might be deficient. So maybe as you're going through it, you find out there's some key part of your model that's not really within the feasible space of the business solution. This is where you would need to validate that the outcome of your model is actually saying something that's executable and valid from your business context. You might test the model on real applications if time and budget constraints allow. So if your model requires instantaneous data for it to come up with a decision, in reality, it may take a month to get the data that you need. So a month-long lag on your model will make it such that this model may not be as useful because you can't get the data fast enough for it. So one of the limitations that you have is that the model requirements may not be practically suitable for the application that you've planned. So this is why sometimes you may need to compromise on the accuracy of the model because at the end of the day, if you have a model that you can't act on, then it's not going to be useful for you in what your client has asked for you to do. So sometimes we are willing to compromise on that accuracy in order to execute and extract value from the model. We're going to assess the data mining results using the criteria that we've set earlier, and it could also unveil additional information about the direction that you want to go with the future of the project. Then you will go through the review process. You're going to do a thorough review of what we learned, what the main findings are from the project, and anything we may have overlooked. You just want to go back and look and reflect on that. You will review the quality assurance issues. So you'll be looking to see if there were any data quality issues that may have had, or do we believe the results that we have? You know, do they make sense? Are they reasonable? And then we're going to look if there are any quality issues that we need to look at, as well as if we built the model correctly, and if we're making certain inferences or the assumptions that our model relies on being satisfied. Potentially when you're making recommendations, if our model is not really performing as it should, it's not built correctly, and so we could be making some wrong recommendations. So we want to go through this quality assessment not only on the data but on the model itself. Then you're going to decide how you're going to proceed forward from this stage. Is this going to be a joint assessment from the project team and the business analysts that you're working with to determine how you're going to deploy a solution going forward? The other consideration for this phase is related to resources for the budget that are going to influence the decision. So this goes back to whether or not we're recommending a feasible model from a budgetary perspective. So the last phase is the deployment and presentation. So you will need to determine how the results will be utilized, which includes who needs the results and how often they'll use those results. So if you're going to deploy the data mining results by scoring a database, utilizing the results as a business rule, use interactive online scoring, or even a simple recommendation of which customers have a higher likelihood of purchasing a product, the knowledge gained will need to be organized and presented in a way such that the customer can actually use it. Because if they can't use it, all of your work was for nothing. So depending on the requirements, the deployment phase can be as simple as generating a report or as complex as implementing a repeatable data mining process across the enterprise. So let's talk a little bit about your planned deployment. In order to deploy the data mining results into the business, it takes the evaluation results and concludes a strategy for deployment. So what is going to be the way we are going to execute the deployment of our data mining or analytics project result? We're going to document the procedure for later deployment and plan to monitor and maintain the model as well. So you're not going to just build a model and forget it. You're going to continually monitor the model to make sure that it's performing as it was intended to perform. This is going to help avoid long periods of time where you're using data mining results incorrectly. So things change, and if there's a change in your business and your model, you're relying on that model, you have some faulty assumptions. And so if you're not continuing to monitor this, you could end up making some decisions that are very expensive for your firm. So you'll need a detailed process for this, and you'll need to take into account the specific type of deployment that you plan to use. So is this going to be a monthly deployment that you're going to be making recommendations? Is it daily? So you're going to be looking at factoring in how you're going to monitor that maintenance. The production of the final report is going to be done by the project leader and his or her team. So it may be a summary of the project and its experiences and some takeaways. It could also be a final and comprehensive presentation of the results. And then you're going to review the project. At the end of the day, what are some experiences that you had? And you want to document some of those findings. This is the overarching summary of the phases and tasks. This is a process that you're going to use for projects in this class as well as projects that you may work on outside of class. It basically creates a good framework from which you can go about doing problem solving, and a process that allows us to continuously learn and use best practices on our analytics projects. The thing that I will leave you with is that you want to make sure that you thoroughly understand what you're doing and why you're doing it throughout the project. As Albert Einstein said, if you can't explain it simply, you don't understand it well enough. So make sure as you go through that you try to keep it simple but not oversimplified, so that at the end of the day, the work that you're doing is being consumed by others, and the analytic solution that we are bringing is simple enough that you can then allow others to use it in a way that can be effectively integrated into their business processes and allows them to explain things simply the way that they can take action from their insight.